Then let me see. Okay. So that's my screen then. And I can probably do this. Can you tell me if you can see my screen now?
Yes.
Let's see. And does it look okay? Because I don't have enough. I don't have my usual computer with me, and I'm still in Germany on my way back to Taiwan. So I'm a little bit limited with respect to what I can do at the moment.
Well, we can see, but it's a little blurry.
Okay.
At least here.
Let me try something then. I can find it.
Kriegen Sie das irgendwie?
Nee, das ist die Übertragung.
Ja, ich bin auch.
Properties. No, there's nothing I can adjust here, I don't think. And it's really quite confusing because everything turns into an infinite recursion if I look at my screen. Oh, there's somebody drew something. Okay. Okay, good. But first, last class we discussed the machine learning approach to computer vision, which is nowadays very popular. We have some high quality models that perform efficiently and well. One thing that I did was I implemented, and I shared the link already. Last class, we implemented a machine learning system to train and recognize cards and their orientations. And the idea was to try and compare what kind of representation would work better. And then here I have the implementation that I did. You can have a look at it. Actually, when I ran the test, there wasn't much difference between the two approaches, so either one would work. So the code here in the GitHub repository that I shared includes version Torch. Like I said, the problem that I had, Torch I think is a little bit more popular than TensorFlow anyway. But I did have problems converting the Google TensorFlow model to the TensorFlow Lite model because of the dynamic dimensions. So I then implemented another version in Torch, and you can have a look at the main file here, which includes the card classifier and the standard setup. So this is pretty standard for Torch applications. They all have this kind of format. So now you would want to add two extensions. One would be to have multiple outputs with the same backbone network. So instead of you, maybe I can at least zoom in for you. Because here's our classifier, and in trained with over 90% accuracy. Our that one outputs the number of classes, which I set to 15, which was just the rank of the card, like ace 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, queen, and that gives you 13. And then I left one for the jokers, red, and one for the jokers, blue. No, one for the jokers and one for unknown, if it's a card that we didn't recognize. And then you would extend that, adding a second classifier, then providing you with two outputs. One is the rank, the other one would be the suit. And that works. Now, for a practical machine learning problem like that, or classification problem like that, what would you actually do? Because right now we were using the synthetic images from Blender, which of course is nice in the sense that you can have thousands of training images with correct annotations, labeling. Certainly a lot more pleasant to do that than to sit on your computer screen and label images. But the problem is that, of course, we're limited to the synthetic data. So how do you think we can proceed to also make sure that it works on the real data? Well, we would have to take images of the actual cards, at least a couple of them. And then what I would actually do, if you want to make sure this works, would be to not use those images that you take from the real cards, you would keep them away and have them as a separate validation set. So the training will be done on only the synthetic images, but when you evaluate your system, you would use both unseen synthetic data and real data. And then if your system works well, you should be able to get a high recognition rate even for the unseen real images. So that is a pretty common approach to try and overcome that issue, or one way to try and do that. Also, last time we talked about the data loader and data set. That's also very, you could code this by hand, but actually using the data loaders and data set for Torch or TensorFlow makes your life a lot easier, because for a lot of the machine learning vision pipelines, there's lots of things that are related to how you deal with the data, like cleaning out data, removing data, splitting training data and test data and validation data, shuffling data so that your training is not following some kind of random correlation within your training data. That all needs to be done for machine learning pipelines if you want them to be robust and work well. And that's actually a lot of code that you would have to implement yourself than just doing that efficiently, especially with large data sets. So I recommend that, even though strictly speaking you wouldn't have to, I recommend using the facilities that both Torch and TensorFlow provide, so that you can make your life a lot easier with that. And then I also implemented so this is recognized cards TensorFlow, which, yeah, so now it's incorrectly called recognized cards TensorFlow. And because it does use Torch as well. And then here, recognized cards Android is the Android app that I wrote, which uses the LiteRT library from Google in order to be able to classify cards then on your Android phone, which is what we want to use as the brain of our robot system. So here's the code for the detector. Ranks, mapping from rank, and suits to integers, so they are defined as enums. And then here we actually call the model and the detector. Load it and then do the detection. Now, if you want to use this code, then that works, but it just depends on exactly what output layer you generate. So I think this one needs to be mapped to exactly how you detect the cards. Okay, now with Professor Gernd, we discussed the course and the course topic, and I don't know why this shows it like that now. Let's take a screenshot. So we discussed the exact topic for the hackathon, and we felt that the Turtlebot is a nice platform, but it would be interesting to have a slightly more dynamic version than the magic trick with the robot, with the wheeled robot and the card detection. And we also realized that the magic show that the rock climbing competition that is planned for October in Bordeaux would be a nice excursion that also the students from Australia may be interested in. So the idea would be that we try and have the hackathon, then our last project, that we would have that geared towards the rock climbing competition. So for the third assignment, yes, the goal will be to implement the card recognition, given the sample code that we provided. But then, and then I think that that's kind of cool. But to actually have the Turtlebot drive around, that may not be so interesting then with the card recognition. That's the only issue. So where's my... Oh, so... So let me find the dates.
Also, wenn Sie das gleich kopieren, was da für eine Aufgabenstellung gegeben wird, weil ich bin jetzt gar nicht im Webgruppen-Raum.
Ich werde das gleich nochmal erzählen, auch mit Details. Aber
So for assignment 3, deadline should be 4th of May, and it will be the card recognizer. If you want to run that on your Turtlebot, you can run it on your Turtlebot. If you want to run that on the mobile phone, you can run it on the mobile phone or on your laptop. But the idea is that you have single cards that you can drop on the table, and the system will be able to tell which card it is, where the position is, and the orientation of the card, so that we could turn that into a full magic trick if we wanted to. Okay. Reinhard was supposed to repeat this, or what was the question before?
No, I will take some time afterwards to dig into details.
Okay, sure, yeah. But you should have everything to complete that assignment quickly. It should be a joint assignment between with Taiwan and Australia students. We used to have a lot more Australia than NTNU students, but looks at the moment we have more NTNU students than. So stick with your previous group. If that didn't work out, we will assign a Taiwanese student to a different group. So you and you don't have to work together with the same group that you worked together with last assignment.
Actually, Jackie, in Germany we have groups of 4, and if they have Taiwanese students, there will be groups of 5. So there's some kind of incentive to have a Taiwanese partner in the group.
Sure, yes, yeah.
So they can ask for the Taiwanese students can ask for a nice treat by the Germans.
Yeah, yeah. They if they meet in Bordeaux, then they should get some gummy bears, I guess, or Jägermeister, depending on their inclination. Yeah. Okay, good. Okay, so this would be assignment number 3. And you have a pretty good start, so this shouldn't actually take that long to complete, and should be quite interesting too. It's a pretty common kind of vision-based classification problem. Lots of applications require you to solve these kind of issues. And we're using a modern approach to doing it, using convolutional networks. Now for the hackathon, we would like to combine this with rock climbing robot competition in Bordeaux. It's
Jetzt zu spät kommt, kriege ich nicht alles mit.
Wow.
Ich erkläre das nochmal.
Wow. Autobahn hat es nicht zugelassen. Wow.
Alles gut.
Wow.
Sie sind da. Gucken Sie sich um.
Ja, gut, jetzt war auch Anzeige, dass heute eigentlich nichts stattfindet, wenn wir in Gruppen arbeiten.
Ja.
Und es fährt kein Bus.
Und auch kein Bus.
Das ist wahrscheinlich auf der Autobahn.
do you have the dates, Reinhard? 9th of October, right?
Yeah, somewhere around this. But this is an add-on. So
Yeah.
I just heard the bus drivers are on strike, so we have to repeat anyway.
The bus drivers to Bordeaux are on strike.
Oh, and here, that's why we only have this small group.
Oh, I see. Okay. Yeah.
They want more money.
Everybody wants more money.
100%, I understand.
So,
Yeah,
Jackie, according to my calendar, it's 28th of October to 1st of November.
28th. Okay. Let me fix it.
Well, actually, the hackathon will start on Tuesday, Thursday. The 28th would be for traveling.
The hackathon in Bordeaux will start on Thursday.
Yeah, on the 29th.
Yeah. Okay. Oh, there will be. Okay, good. So the idea would be to do something with that. Now, even the issue is that the Taiwanese students have built small humanoid climbing robots. You could do the same at Ostfalia. Or we do it in simulation, which we did last year. And what are your thoughts on that, Reinhard?
We will go with simulation because we will not be able to build that many robots with the entire course. But whoever wants to may start with the building robot. And then everybody will make up her mind to join the to join the workshop in Bordeaux, and then they should have time to actually build the robot. They either simulate it or start building.
Yeah, okay. That sounds reasonable. So that means that we need to release the rock climbing. Yeah, we need to release the rock climbing simulator.
They could apply Gazebo, because everybody who sits here did this simulation of Turtlebot. So this would be applying that experience to new kind of robot.
Okay. Good luck with that. I think Gazebo is really not that easy to work with, and implementing a humanoid climbing robot in it, the accuracy of the simulation is significantly better in Mujoko. That's why we picked that. But if you want to use ROS and Gazebo, then that's also possible. Okay.
An option. If anything is possible. So if they prefer that one, if they prefer Gazebo, that's fine. If they prefer Mujuko, it's fine. It's the basic knowledge about simulation, which is
so the hackathon then, and the way that I will proceed with my sample implementations
If you like, go for Mojuko.
Not quite. But yes, you could adapt it to whatever you're interested in your lab or your personal feelings about simulators. Let me just copy this.
Well, Jackie, one of the objective of this course is everybody knows a gazebo. And we did this. Everybody pretended to know gazebo. So we can put a check mark to that.
Yeah. I just have to find the simulator link.
Didn't you provide that one already?
No, it's a different simulator.
Okay.
I mean, I provided it
Last year.
last year, yes. Oh, how come it says I have 142 results and I can only scroll through a couple of them? Okay, so the first one. So here's a link to the GitHub repo, which is a web-based technology, 3JS-based simulator, just working on the kinematics, so it doesn't do any dynamics, which we did 2 years ago, I think. Yeah. And but the one nice thing about it is that you can actually oh. So we did a web-based technology simulation, and that's why this runs in your browser. It's just downloaded from GitHub, and then the bear can actually climb up this particular wall here. The routes were set by our okay, my computer is not very fast. The routes were set by the climbing coaches at the gym in Taoyuan. And I think that is actually you can also go to this URL yourself and play it on your computer. It'll probably run faster, and you can zoom around and everything. So you can play around with this yourself. If it doesn't do the planning anymore, then I can actually zoom in and pan and everything easier. Yeah, and here you can see the model that we have of the Taiwan bear. I didn't model it based on a particular robot because I thought it'd be fun to have. I also made a monkey, but I don't know what happened to the monkey. So for this year then, the next iteration of this was that we used MuJoCo as a simulator as opposed to just the kinematics using Three.js. So I just have to find that.
This much about having a good documentation.
Okay. So can I actually upload a file to this Big Blue Button?
Probably not.
Can you?
Probably.
No? Okay. Then I'll make it available some other way. But anyway, so how many of you have actually installed Gazebo already? Or worked with it? All of you?
Yes.
Yeah, okay. And how easy was it?
Ah,
How long did it take you?
3 or 4 hours, maybe.
Okay, then you're very fast. Usually my students, it takes at least 2 weeks before they have a working version of ROS and Gazebo set up on their laptops. So if you've done the work already, then it makes sense to continue with Gazebo. However, I like MuJoCo because the physics simulation is potentially more powerful. And also to get it working, it's under Windows and Linux, it's like a 20 megabyte download, and you have a very powerful simulation system accessible and available. So for my goal then, certainly so my approach would be to use MuJoCo with the WebASM backend. So MuJoCo can be compiled as a application, but it also can be compiled against WebASM, which is the JavaScript engine assembly language kind of compiler. That allows you to run any kind of programming language that supports it, that supports compiling against WebASM as an application in your browser. So that means you don't need to worry about downloading or installing any dependencies or anything like that. You just go to you just retrieve the app from the server and it should run on your computer then. This is extremely powerful technology nowadays. It allows you to run large language models even in your browser. Web GPU based programming is all possible. So I like it, and there's a lot of momentum behind it. The capabilities keep extending and expanding every year. And with MuJoCo, that means I could do the same thing that I did previously, where I just showed you the robot climb, except it would be running the MuJoCo simulator with the Taiwan Bear. So this is what I would try to do this term then. And as far as the climbing is concerned, I would suggest that we try and do a slightly more interesting movement. If you look at the climbing for the bear that we have so far, it is exactly 3 holes and then 1 arm moves. So maybe we, instead of climbing up the whole wall, we focus on just swing or something like that. So that you need to do 2 hands and then the whole body swings over and then you reach to the next hold. But I haven't decided the exact challenge that we pose. So let me finalize that. But then that will be for the 4th assignment, the hackathon, the Ostfalia hackathon, as opposed to the rock climbing robot hackathon in Bordeaux, would be to use a simulator, construct a robot, a virtual robot, which could be a real robot that you have, or it could be a fantasy robot. So if you want to have a a bear or monkey climbing, or if you recreate Donkey Kong, if you enjoyed that game, then you can use that as your actor, as your avatar, in order to do the climbing. So I can post the links actually to our Discord server, and then you can download the files from there. Or and another interesting GitHub repository that you may be interested in for this kind of thing would be the Mujoko Menagerie. Which is a collection of playgrounds, robot models that you can use for your work or for your assignment. So in particular, this one also has a model of the OP3, which is a humanoid robot that many research labs have available. If you want to have a model, and you can, of course, these are all done using STL files. And also as URDF files, so you can import them into Gazebo as well. So you don't have to make a model of a humanoid robot if that's what you want to. You don't have to make the model from scratch. And then I need to go here. Okay. Yep. So the first file that I posted is a Blender file that includes different climbing holes and the wall. So you can build up an environment out of that. And then a Mojoko-based initial simulator setup that allows you to then add your own robot and have it move around in the simulator, applying torques to the joints and things like that. Similarly to what you would do with Gazebo. So in theory, there's not much difference as far as using the simulator is concerned. Simulation of the real world is a very difficult problem. Simulation fast enough so that you can do it in real time or with not too much lag, which not too much slowdown is even harder. So whether you use, and the problems are all pretty much very similar. So whether you use Mojoko or Gazebo is not going to have such a huge impact. But the only difference is that Mojoko is just a lot easier to install. So if you have already worked with Gazebo and have it installed and have it running, then you should probably just stick with that. If you would like to try a different simulator, especially with the web technology, then you can do that. Okay, good. We complete the vision pipeline for our magic trick. And the hackathon, then the project hackathon assignment 4, whatever you want to call it, will be on rock climbing robots. That. So, any questions?
No questions? Good.
Or comments? Okay. Anyway, you should have a good start for assignment number 3 already. The train your model and have it detect cards. And then in the meantime, you can consider your approach to assignment number 4. And basically what we would like to have at a minimum, what we need would be kind of a visualization of the robot climbing, like the GitHub link that I posted. But we will, of course, modify the exact challenge so that, and most likely we will go into a more dynamic scenario where we need to do kind of a swing or a jump or something like that.
Yeah.
Okay, then I don't have anything else to add for now. Reinhard?
Yeah, I will add a few more things, but I think you wanted to go, at least you should get some medication.
Yeah, I do. I do have a cold, and yeah.
Okay, so I will explain a few more things, and then we carry on because we still need to do some practical work, which actually was foreseen for today.
Yeah, sure. Yeah. Hmm. Absolutely.
And I may need to clarify a few more things, otherwise somebody will complain.
Hmm.
Okay. There's still some students from Taiwan there as well.
Hmm.
Justin, I recognize, and some Chinese characters at the bottom. Yeah. Okay, so
Yeah.
we keep this open and we stay in English. Okay, for the practical work, it has been mentioned before. We have groups of 4 German students, and we have a limited number of Taiwanese students. If you want to have additional help, you should get one of the Taiwanese students. They may have a little bit more background, for example, with respect to Majuko or stuff like that. They may have access to the to real climbing robot for the later hackathon. So there should be a benefit in it. But not all of you will be able to do this. Not all of you will be able to find one of the Taiwanese as a partner for your group. Mixed group, 5 members. Purely German groups, 4 members. That's about the rule. Yeah, we will continue with the TurtleBot. So the first, well, last week we had this nice conference, and they defined a nice scheme for robotics engineers. And they had this kind of T shape. So a robotics engineer knows everything about all the fields of robotics, hardware, software, dynamics, all these kind of things. But he's not an expert in this. And then he has one column of this T bar, one column where he is an expert. So he knows about hardware, but he's an expert on software. Or he knows about software, but he's an expert in hardware, something like this. So this is where we want to go. This is to some extent what the book does. And now we also want to explore a little bit more into depth. So maybe you will kind of complain, that we have to do Gazebo and we have to do Majuko. Or we have been encouraged to do both. The point is, Gazebo, if you go to research, you will have to work with Gazebo. If you go to companies, you may have to work with Majuko. So if we all agree that all you guys will go into research, then we don't need Majuko. Well, probably we will, because a lot of other researchers start using this. So these are the 2 simulators which are most relevant at the moment. There's some commercial simulators out there with specific properties, but you have to have money for those, because you have to pay license fees if you use them commercially. So Majuko and Gazebo are the most relevant ones. We will cover a couple of things. The TurtleBot is a good sample to get a practical overview. The book we are looking at is a theoretical framework, and the TurtleBot is a good practical framework because it covers all the aspects, installing the operating system, putting together the hardware, dealing with noise and so on. So coming to the TurtleBot, the first task is to learn simulation, and I think it's the best approach to get an a fast start into ROS and gazebo simulation. But we also want to go to the real thing, so that's why we have these groups and working with the real Turtlebot. And we will do the magic trick with this Turtlebot. It involves image detection, the stuff we're doing, or Professor Baltus is doing, to detect the different cards. We will have some interactive aspects, how to interact with the environment, and we have some navigation aspects to actually act with the environment. So the robot has to approach close enough to the cards to do the detection. It has to interact with the user in some way. So that's the part that's covered there. HRI, human-robot interaction, is another one of those overview parts, like human-machine interaction. Yeah, and eventually we want to do this hackathon. That will be the final part. And this is this is kind of a challenge. So it should let you show how to apply your knowledge to a new field. Typically, this would have been done as a hackathon at very short notice, so very condensed. But we will leave more time to this for you. You could, as Professor Baltus pointed out, you could use some available robot. You could possibly use the robot that are available in Taiwan. So if you have one of those Taiwanese students, you could use that one. You could design your own one. And the very basic approach would be using these kind of standard servos. If you're into model cars, model boats, stuff like that, you would probably know them. We have a bunch of those, so if you like building them, which may not be a good idea to squeeze everything into the semester, you would have the opportunity. But at least you should do it in simulation. So they're different depending on your ambition. Either you use some available robot. Well, you could even only use the bear that is provided by Professor Baltus. I would expect you go a little further. So you use the model of a real robot, which then could be used for the event in Bordeaux. Or you build your own one. You could use these kind of service because they are available and we could use them. You could go for some fancy high-class servers from a company. But we will not be able to build those because we may not be able. We have some servers, but we don't have the budget to buy specific servers to your needs. Okay, and this will be the stuff we do with a lot of practical parts. I also prepared some more information about dynamics. Talking about the climbing, Professor Baltus pointed out dynamics. You could do kind of a static climbing, like you can do a static gate. If you have, let's say, a bipedal robot, you can make sure that the body weight is always supported by balancing the center of mass above the support polygon provided by your foot. So you can stand on one foot. And you can also move this way. You lift one foot, you make sure the center of mass is always above this one foot. The other one is free. You can move it around, and then you place it someplace else. By then, you have support area provided by one foot and by the other foot. So you could move your center of mass above one foot or above the other. And there also is a kind of virtual support area, which is defined by the connection of the 2 feet. And so in order to move forward, you shift the mass over 1 foot, you lift the other foot, you put it forward, you generate the support polygon between the 2 fields, you move forward the center of mass between these 2 feet until it's fully above the 4 feet, and then you can lift up the hind feet and do the same again. So that's a kind of static locomotion, static gait. And you can also do a dynamic gait. That's the difference between walking and running. When running, you have this kind of light phase. Well, you could do it with 2 legs. It's like hopping, but it's more efficient if you change the legs in between. And well, you may have witnessed Olympic competitions. There's a walking competition and there's a running competition. And the difference between the two is that the walkers always have to have 1 foot on the ground. And that's why it looks so funny. This kind of dynamics, of course, is a little bit more complicated. And we could do some kind of dynamics for the climbing too. And it's up to you where to apply. Well, the first step, of course, is just going for a static gait like the bear. And then maybe the next one is to applying some dynamics. As the real good climbers do, they attach to some of the climbing stones and then they swing over to another one and they have to grab the other one, like Tarzan, huh? Swinging from one tree to another. Yeah, and you should do some research on this and define for yourself which approach you want to follow. But the more advanced, the more daring, the better for you, because this will help you to advance your knowledge. Any further questions towards this? Okay, then today we will do the continue with the group work. You all showed the Turtlebot simulation. Now you need to move to the real Turtlebot. And you need to deal with the camera, with the card detection. Did anyone bring some cards, game cards?
There's a data set online.
Okay, yeah, but if you want to do it in real, then otherwise I will go and get some. But
now the assignment fee, it will be virtual or she have to go to the lab?
There is some hiccup between the numbering. So the previous assignment that was virtual, operating the Turtlebot with the teleop keys. The next one, doing the magic trick, that's real, but the magic trick consists of many steps. First step is operating the real Turtlebot. That's why you have the SD card. You need to install the operating system. You may want to do the teleop, the remote control of the real Turtlebot, and then you need to carry on. The next after that would be to use the camera to detect the cards. And then after that, it should be implementing some locomotion to do the trick, because it's not just sitting the robot on the table. It's also moving around, having a look at the different cards, making sure you detect the cards properly, stuff like that. And also to have some interaction with the human counterpart, because did Professor Baldus explain to you the trick, how it works? So it's a lineup of cards. The user takes some card, and well, the robot, of course, has to turn around. It's not watching, oh, there's a gap, it's this card. So the robot has to turn around at least. And maybe also has to do some other fancy movement, whatever your story behind this is. And then, well, the idea is the user memorizes the card with his brain. He puts it back. Well, there's some motion. He puts it back, and then the robot finds it's this card. So assume there are 5 different cards. User picks up one of those, puts it back, and the robot says, well, you pick this card, or I read your mind, it was exactly this card. Yeah, that's the magic trick. And there has to be a camera, locomotion, and some kind of interaction. But we don't have audio output. Otherwise, you would do something like a real magician. He will tell a story.
And we have to record the video, then show you, or by posting?
Whatever you do, you should do a video because that's your backup solution, and you should show and you should be able to explain.
During the video?
Not during the video, in real.
Okay, real.
So unfortunately, and that's why we're kind of we're still fighting over the kind of examination, because typically in homework, or in the past semesters in homework, we had a lot of AI generated stuff. So some of your fellow students provided some solution written by ChatGPT, and they were not able to explain. And this is not what we do. We're not ChatGPT clerks here. We try to become engineers, and this is what we need to figure out how to do this. It would be unfair for some guys spending all the time to prepare some solution, and some other guy with a prime attachment to ChatGPT or whatever, just ChatGPT, write me a program to do this, and then, oh, this is my result. So the grade shouldn't go to you, it should go to ChatGPT. Huh? And in order to make sure that's really by you, we need to find some way. And we could talk about this a little bit more. One of the issues, ChatGPT learns from what human did in the past. And now if it's only ChatGPT learning from himself, there will be no more advancement. ChatGPT makes mistakes, and it takes a senior engineer to find these mistakes. But if there are no more senior engineers who know what they're doing, who know where to look and to verify the results, then there will be no more progress. So that's the idea. You can use ChatGPT, you can use AI, but you're responsible for the result. And always assume you only have one shot, one try. Like an escape room, where the exit is locked forever if after the first attempt. So please take it serious as a thought exercise. But
how will the robot know which card has been hit?
that's part of the trick. I don't want to steal it from Professor Baltus, so he actually is the magician. He will tell you. It's by image detection. So actually, there's some indicators in the cards.
Does the card have changed or something?
That actually could be a solution. Maybe you can improve the trick. Yeah. Which may require very precise locomotion, but it's an obvious approach. I think he will tell you. You just have to be able to detect the cards, the different cards. Okay. Ist das nicht das Randstadt-Logo?
Nee.
Ich weiß. Nee, ich meine, aber auf der Kappe.
Hoffentlich. Hoffentlich nicht.
Okay, who wants to go to the lab?
We have to be registered, booked.
If there's a free space, you don't have to be booked. If you want to make sure you get the space, you have a free space, then you should book.
Das ist immer ausgebucht, man hat selber gebucht und dann ist alles frei und ist alleine da.
Ja. Okay, Sie sind ja eine Vierergruppe, ne?
Ja.
Genau, haben Sie einen Kollegen aus Taiwan dabei oder kennt er Sie nur auch?
Jetzt nicht.
Ja.
Okay, lassen wir die Taiwanesen für die anderen. Ich würde Sie dann gegebenenfalls nochmal bitten, wenn das notwendig ist.
Aber die waren doch bis jetzt auch untergebracht.
Die waren untergebracht, ne? Aber vielleicht könnten wir mal mit ihm können wir mal so ein bisschen angeben. Ne? Genau, ach ja. One more thing about Bordeaux. In October, we will do the trip to Bordeaux because there's an international workshop, whatever we would like to call it, a hackathon. We will do this as an excursion, and if you're interested, it's next semester. It's not related to this course. You will have passed or failed this course by then anyway. You may want to join the excursion. And you may need, well, you will for sure need to pay for this. Excursion, it's supported by the university, but it doesn't cover everything. So there's a rule, minimum of 20% have to be covered by the students. Bordeaux is a nice place. We'll do this at the University of Bordeaux. It's a very good French university. And it could be an option for you to advance for doing some project work there. If you're French, anyone speaking French? Yeah, yes, natürlich. It would be an option at least for project work. Yeah? If your French would be sufficient, you could also study some subjects there. But that's purely optional. They will bring some robots, for example, the Taiwanese. You would have the option to build the robot by yourself and then compete against the others. Yeah, that's the two options. There are some robots available. There will be some robots available there, but you could also bring your own. And then it will be a little bit of fun.
And is there a registration period for this?
Yeah, we will publish this, and of course, the members of the course will have priority. We don't have space for 80 students. Probably it will be around 10 to 15. But I don't expect very many more to be interested. Good. So,
Ja, wollen wir dann mal rübergehen? Ich habe hier eine Karte von der Gruppe.
Haben wir den Kartenleser?
Ich weiß aber nicht, ob der noch funktioniert.
Du hast was, er hat was. Wir haben ja auch so einen Adapter.
Ohne von Karten. Aber
der funktioniert auch, wenn ich weiß, warum die nicht so.
Ja, dann lass uns doch rüber, oder?
So, Kevin, Justin, the teams will be working on it now, and David. So try to get in contact with your teams.
Ja, wir haben hier.
So we even if we have to I go there and that
Ja, das Visual ist schon ist ready to trainieren. Ja, 2 GB Daten.
Das scheint auch irgendwie nicht so kompliziert
Das ist genau das, was ich schon mal trainiert habe.
You just watch film that will and we can book appointment one day. We can do have you booked or decided because as you can for Saturday.
We don't even have access for the lab. Now I think he told me that by this week we'll be having that access. You have sent him that matriculation.
No problem. I think we can do this.
I sent it by email. By email. The same time you told us. Yeah. Okay, so maybe you can check up on this. If we got the
How it's
access.
work, then we have to understand here.
Yeah.
So we just have like one turtle bot robot in the lab.
No, there are
It will be more.
I think 8, 10 I've seen.
Then we can use like one of them. They are going to work in one or two.
I think like using it, it's not a problem. It's about
Doing it right.
the space
Okay.
in general.
Yeah.
Because you need space to move it. And, like there's a track, something like that. Let's see.
We'll see.
Yeah.
If there isn't, it is not for us. Today, at least we can watch and understand how everything works. So next time we will work smoothly.
Exactly.